Hello everyone, myself Dr. Prateek Garg. Today we will discuss about pure tone audiometry. So by the name itself suggests it is a test to check for the audiology or for the hearing by means of pure tone. So what happens, we deliver the pure tones into the ear of the patient. So by means of pure tone, we just check out the hearing threshold of the patient. So how we do it? These pure tones are being produced with the help of a audiometer, or we can say audiometry machine, and then these pure tones are being delivered into ear. Generally, the intensity of this pure tone are increased or decreased in a gap of 5 decibel. That means we increase the sound energy by means of 5 decibel every time. Generally, the air conduction and bone conduction both are measured by means of pure tone audiometry. So suppose this is a graph of the pure tone audiometry. So we give the dB, that is the decibel sound, in form of pure tone, and there are various frequency are being labeled in this horizontal line. So air conduction, that means the conduction through the air, or we can say through the middle ear, ossicles, tympanic membrane. So this air conduction is tested from frequency 125 Hz to 8000 Hz. Whereas the bone conduction is being tested from 250 Hz up to 4000 Hz. So, and then this charted graph is being obtained, which is known as audiogram. Now look at certain symbols which we use in the pure tone audiometry. R, or we can say red color, denotes to right, R for R. So red color symbol are basically towards right ear. Round, R, again this is my round image. So again round circle, these are also denoting the right ear. So by means we can just recognize, or we can remember which symbol is for the right ear and which symbol is for the left ear. So red is for the right, round is for the right, then comes the cross is for the left, then comes a triangle is for right, and the square box, it is for the left. For the bone conduction, we use different symbol like the arrow. So generally arrow facing towards patient right. See, patient is sitting in front of me. So if suppose patient sitting in front of me, so patient right is like this, like this. So arrow pointing towards right, and then left side is arrow pointing towards left of the patient. So in this pure tone audiometry, we will detect about the air conduction and bone conduction. So this 0 to 25 decibel gap between the air conduction line and the bone conduction line is considered normal. If this air conduction and the bone conduction gap is more than 20 to 25 decibel, then we can say it is a conductive hearing loss. And suppose this air conduction line and the bone conduction line gap is not more than 20 decibel or 25 decibel, then this will be a sensory neural hearing loss. Let's get a proper idea by means of diagrams or by means of this pure tone audiometry or audiogram. So this is a normal audiogram where you can see this is the 0 decibel. Okay, the point to remember is this 0 decibel doesn't mean zero sound. It means the level of the sound energy perceived by a normal patient, or that is a normal hearing threshold of the normal person. I mean, if I'm normal, I'm having a normal hearing, so the hearing threshold of the normal person will be denoted as 0. So in the normal audiogram, as you can see, this cross and this arrow, they are pointing towards the left ear. They both are at the same level without any gap between these two types, that is the air conduction line and the bone conduction line. There is no gap, and they both are continued present at the level of the 0 decibel. That means the patient is hearing quite equivalent or similar like a normal person hearing. So it is a normal audiogram. Now look out at this conductive hearing loss audiogram. As you can see the arrow, suppose this is for my left. As you can see, this is for the left. This arrow stands for the left, that is pointing towards the left side of the patient. And this cross is for the left ear. So these are cross and round, they both are just imposing over each other. So we can see in this patient, this is a line showing the bone conduction, the upper one, and the lower one is a line showing the air conduction. So you can see in the patient, the bone conduction is normal, which is at the level of the 0 decibel, that means equivalent to the normal hearing person. Whereas the air conduction, there is decreased air conduction at the level of 35 to 40 decibel, and there is a gap between bone conduction and air conduction, showing the conductive hearing loss, because the gap is more than 20 to 25 decibel and the bone conduction curve is normal, air conduction curve is below. So this patient is having conductive hearing loss. Now look at this chart, which is a chart showing the sensory neural hearing loss. Look out at the pictures. The red color denote for the right ear. So you can see also circle, they are also pointing towards the right ear. So look out at this bone conduction line and the air conduction line, both are going downwards at the level of higher frequency, that is starting going down from the 1000 Hertz until the level of the 8000 Hertz. These are going downwards like this. So this is purely a hearing loss, since there is no gap between air conduction line and the bone conduction line. So this is not a conductive hearing loss, but since there is a loss, patient can't hear at 0 decibel, he has to hear at the 50 decibel or 60 decibel at the level of the 4000 Hertz. So it is an audiogram showing the sensory neural hearing loss, where there is no gap between air conduction and bone conduction lines, but the patient hearing threshold are going down. He can't hear at the level of the 0 decibel or 10 decibel. We have to give a 50 to 60 decibel of the pure tone so that patient can hear. So this is sensory neural hearing loss, basically at the higher frequency. Now look out at this diagram, which is an audiogram showing the noise induced hearing loss. Now this is the pathognomic feature is dip at 4000 Hertz. So this is my 4000 Hertz frequency. So typically in noise induced hearing loss, there will be a dip in the bone conduction line, not in the air conduction. Particularly in the bone conduction line, there will be a dip at the level of the 4000 Hertz. So this is pathognomic of noise induced hearing loss. As you can see, there is a dip at the level of the 4000 Hertz. It is also known as acoustic dip or boiler maker noise, because the person who are involved in the making of the boilers, so they have to deal with a loud sound. So a study was conducted and it has been found that they were having a typical dip at the 4000 Hertz. So this is an audiometry showing the graph of noise induced hearing loss. Now let's talk of otosclerosis. So dip at 2000 Hertz only in the bone conduction line is pathognomic of otosclerosis. I want to mention here, this is bone conduction line only, not the air conduction, and this has been asked in the previous paper. So in otosclerosis, whenever there is a decrease or restricted mobility of the stapes bone, so the bone conduction graph will present with a dip at the level of 2000 Hertz. So you can look out at this diagram, there is a dip at the level of 2000 Hertz in the bone conduction line, whereas the air conduction, there is also air conduction line is going down. That means hearing is impaired, and there is conductive loss also because the air bone gap is more than 20 to 25 decibel. But there is no particular dip at the level of 2000 Hertz in the air conduction line, whereas there is a dip at the level of there is a dip in the bone conduction line at the level of 2000 Hertz. So this is pathognomic of otosclerosis. Why it happens? Because the stapes bone, the threshold if we call it, so that is the stapes bone, that is at 2000 Hz. We used to say the resonant frequency at which the maximum vibration of stapes bone occurs, at which Hz. So that is 2000 Hz. So whenever 2000 Hz sound is being delivered to the patient, so that is a resonant frequency for the stapes bone, and because of the autosclerosis, patient can't perceive that frequency properly, leading to a dip in the 2000 Hz. Now the last one is congenital sensorineural hearing loss, which has been seen also in the cochlear autosclerosis. Here what we get is a U-shaped graph. You can see this is like this. Okay, so this is somewhat like a U-shaped graph, or it is also known as a straw shape or a cookie bite. How does a cookie bite will look? Suppose this is my round cookie. Whenever we bite it like this, so this half part is gone. So this graph is like a cookie bite. So this graph is a typical of the congenital sensorineural hearing loss or cochlear autosclerosis. Now there is one phenomenon which is being used in the pure-tone audiometry, that is known as masking. What do we mean by masking? In masking, if suppose we want to test for one ear and other ear may hamper our result because patient may perceive sound from the other ear. So we need to mask this non-test ear. So how we can mask is generally we provide some ambient noise in the other ear so that it will get engaged into that ambient noise and we can test for the testing ear. Generally, when it is done for air conduction, if the air bone gap is more than 40 decibel, then masking is preferred. For the bone conduction test, it is generally always preferred. So I hope that is all. That is, you must be clear about the